Hi guys, welcome to ramanujan.math.circle, and today we're going to be covering the second part of algebra. So let's get into it. All right, so first we're going to start out by covering speed, time, and distances. So let's go into the definitions of these and how they're related to each other. First of all, speed is often represented by s, and d is represented, distance is represented by d, and it's traveled along a path. And then the total time taken is often represented by the letter t. So keeping this in mind, let's look at some relationships between the three variables, d, s, and t. So we can say that speed is equal to distance divided by the time. So that's one way to write the relation. We can also say distance is equal to speed times time. This is the most common way of remembering the relation between the three of them, because when you multiply a speed of something by the total amount of time it took, then it's probably the distance. And one thing you can remember is, for example, speed generally, when we think about it, it's like miles per hour, for example, right? Time can be in hours. When you multiply these two, it's miles divided by hours, right? Miles per hour, and times hours. So that cancels, so it ends up being miles. And that miles is the measurement of distance. We can also say that time is equal to distance divided by speed. Again, this is the least common one. Least common. I would just remember it this way, easiest. There's something called an average speed, and what average speed is the total distance divided by the total time. So if, for example, a traveler goes travels d1 distance in t1 time, d2 in t2 time, and so on and so forth till dk in tk time, the average speed is represented by the sum of all the distances divided by the sum of all the times. Note that the average time is not necessarily the average of this. The average speed is not necessarily the average of all the speeds, because this is not necessarily equal to d1 over t1 plus d2 over t2 plus all the way till dk over tk divided by k. This is not necessarily true. I mean, it could be in a very special case, but that's not true here. So make sure to realize that you have to sum up all the total distances, and you have to sum up all the times to get the total time and divide. Okay, so now let's look at a concept called relative speed. Relative speed is basically the speed of an object A, for example, relative to another object B, and object B is generally moving. So the way we can go about this is we keep one of them static, one of the objects static, and then we see the movement accordingly. So the relative speed of A with respect to B is S of A, meaning the speed of A, plus minus speed of B. And I'll go into when you use the plus and when you use the minus. So by plus or minus B, what we're basically doing, like I said, is making B static. So let's say this is A and this is B. You're going to keep okay, so you have initially SB and you have SA. So you're going to turn SB down to 0. And that means you're going to have to turn SA down to SA minus SB. Correct? So that's one way you can go about it. And that's if we'll see the scenarios when you do SA minus SB and when you do SA plus SB. So without further ado, let's try to look into that. Okay, so if A is running behind B in the same direction, so let's say this is SA and this is SB, then use S minus SB. And the reason is because when you keep it steady, so let's go to our keep B stable case, keep B at 0 zero speed. So when you do that, you get, so this is B, this is 0, and then this would be SA minus SB. You're subtracting both by 0, both by SB. It's kind of like a balancing an equation. You can't, you have to subtract the same speed from both objects. Okay, so that's when the speed of A relative to B is SA minus SB. What if A is running towards B? So what if it was like this, and it's like SB this direction, and SA? Well, in this case, if we reduced B to 0, then that would actually mean adding B in this direction. So we're going to count this as a positive, and we're going to count this as a negative. So that means we have to add SB, because if you notice, logically, if you think about it, if both of them are moving towards each other, B and A are going to get closer and closer to each other really quickly, because A has a speed and B has a speed. So they're going to get closer to each other. So if we subtract, that's actually going to make it slower, because the gap between the two of them is going to take more time to, close, I guess. So hence you add SA and SV. So that's your new total. So the direction in which you set up your speeds really matters. And the main point here is that when you look at relative speed, you want to see what happens when you keep one of the objects at 0 speed and measure accordingly. And remember to balance the equation and add or subtract accordingly. So let's look at an example relative to speed. Related to speed, my bad. So I'm going to read this. You can have some time to solve it, and then we'll come back and discuss. After school, Maya and Naomi headed to the beach 6 miles away. Maya decided to bike while Naomi took a bus. The graph shows their journeys, indicating the time and distance traveled. What was the difference in miles per hour between Naomi's and Maya's average speeds? So you kind of want to go back to the definition of average speed probably, and try to determine the average speeds of both girls, and then find the difference. So that's kind of the outline of steps. I'll let you work on that.